next one. So now what we did was just fitting a curve, which is kind of an abstract problem. So let's move on to computer vision. I was very happy to see this one. And I got these first two from a textbook, by the way, and the rest I got from like blogs and stuff. And the links are at the bottom. So, image is not printing? How rude. Well, that's very annoying. I'm going to go look up the image. I don't know why it's not printing on my links here, but I'm going to find it here. There, this is the image. And I'm going to open it in a new tab. Somebody put this up. They went to some clothing retailer and they got pictures of all the clothing. So they have hundreds of pictures like this that are just a shirt and some shoes and some pants and stuff like that. So this is a realistic machine learning problem. Not that different than, say, what the Tesla does, right? The Tesla looks out your windshield and it tries to figure out, is that a dog? Is that a child? Is that a car? Where do I have to go? And I've seen videos of people driving Teslas when it gets confused. Like there's something weird going on, like a person walking across the freeway with pushing like a shopping cart, and they can't figure out what it is. They think it's a cab, they think it's a dog, and they can't figure out whether they should stop or not. Anyway, so this is an issue. You have these little pictures, and you're just trying to sort them into categories. So let me get, all right. Here's the categories: t-shirt, trouser, pullover, dress, coat, sandals, sneaker, bag, ankle boot, and so on. There are 10 possible categories, and there's a whole bunch of images in each of these categories. And so you're going to make a neural network like what we saw before. We're going to have a series of input. We're going to have inputs from all the pixels in the images, and then some hidden layers to do the work, and then 10 outputs for the 10 categories. And the strength of the output will determine which category it's in. So here's the plan. Each input is going to be 28 by 28 pixels, black and white, a number going from 0 to 255. The first layer has 128 neurons, and the second layer has 10 neurons. So there's only one hidden layer. So here's the input images here. You break it up into all the pixels and put them here. Then all those pixels go to all the hidden neurons, and then all the hidden neurons go here, and that determines the probability that's a coat or a sneaker or a bag or whatever else it is. That's what we're going to do. So here's the entire code to do that. Start here. All right, there we go. Get rid of the old stuff and put in the new stuff. All right, so it defines training images and training labels, and it loads the data from some online resource for this data. I think this actually comes built into the model, the fashion set from MNIST, which I think is the National Institute of Standards. I think this is some image that's been provided for people to learn machine learning from the government, which is nice. So anyway, it makes training images and test images, which it takes, I think, 3/4 of the data to train on and 1/4 to test it on, which is a common thing you do in machine learning. You use some of the data to learn and the rest to test to see if you got it right. And so now we make a model. It's the same thing we've done before. We use the sequential. Then the first layer is 28 by 28. That's all the input pixels. The next layer is 128 neurons, just to do the processing. And the output is 10 neurons to indicate the 10 possible categories. And then we compile the thing, and we specify how it's going to determine the loss and what optimizer it's going to use. And there are several different types of optimizers and loss measures you should use, and I haven't really gone into it much. And then we fit the model. This is training. And then we evaluate the model on the test data. And that's it. So that's old run. I think I got to run a new one here. All right. So I run it. There it goes. Downloading data from someplace it's downloading that standard data set. Now here it is calculating. It's only going to do 5 epochs of training here, but each training is going to take a while. So you see we have a progress bar. It takes, it looks like 7 seconds to do each cycle of training. It's not too bad, but it's doing a lot more work. All right, that's the last epoch going. By the way, we should be able to see the accuracy. Wonder if I can drag this over and make my window wider. See the accuracy. All right. Yep, there's the accuracy. So it started with an error of 0.8. Oh, I guess it's percent right. So it started at like 82 and it made it up to like 87% right. This is 87% correct. And here's the test data, which it also got 87% correct. So that's pretty good. our model is now up to 87% accuracy, which, you can argue whether that's good enough or not. But anyway, I hope Tesla is better than that, for example. That would be a 10% chance of misunderstanding what you're seeing and presumably running over somebody. But anyway, we're up to 87%, certainly a lot better than chance. All right, so let me go to my instructions here. And then, that's not the right one. It was this one. All right. All right, and so now we can view the results for 20 test images. We can see it's only 87% correct. That means there are a considerable number of errors, so we should be able to see the errors. And since this is Python, it's very easy to write the code. It didn't take me long to figure out how to do this. I can take the first 20 test images, and I can just print out the results for them in a little chart here. All right, so let's go up here. And if you're doing like the 123 class and doing some Python there, you're learning enough Python to handle this kind of stuff. That's why Python is your best first language, because it's really pretty easy to use. So it's going to print the first 20 image results. So there it is. So the right answer is 9. And 9 is these columns are from 0, 1, 2, 3, 4 up to 9. So 96% chance of 9. So this one it got correct. This one is 2, it got correct. These ones are 1 and it got them correct. There's one of these 7s that it gets wrong. This 7 it got wrong. The right answer is 7, 0, 1, 2, 3, 4, 5, 6, 7. It happened to get it right, 75% 7, but 22% 5, but it was pretty confused about it. And I thought I found one it got wrong before. I think it actually got this one wrong before on me. It had the 75 and the 25 fixed. So let's take a look at that one anyway. This is one it got wrong sometimes. I say there's some randomness. It got it right this time. But there are plenty it got wrong, and we could probably find another one it got wrong if we hunted through this chart more carefully, like this one. 0, 1, 2, 3, 4. Yep, this one it got wrong. 3, 2 is 59, and 4 is 37. So this line it got wrong. So that is number, this is 0 to 19, 18. That's number 17. Let's see if I can print out number 17 and find out why it got it wrong. If I go to here, all right, this will, right, here I printed out a couple of the images, and before I did number 11 it got wrong. This time I think it was 17 it got wrong. I'm going to replace that by 17 and compare it. Here's the first one it got right. Here's going to be one it got wrong. So let's try that. All right, I'm going to make this 17 just so I can perhaps match my example there. Okay, so it's going to print out 2 images by using a plot. This just where you can see what they look like. So there's the first image, which it got correct. And there's that 17 image, which it got wrong. And I guess I can see why I got it wrong. That doesn't look like much of anything. Well, I guess that's a bag, like a purse, but a shirt? Yeah, I mean, I couldn't tell if a purse or a shirt or something. Anyway, I can see why I got it wrong. That's kind of a messed up image. And the other one before that I thought that I got wrong last time was number 11. Let's take a look at number 11 also. Just run that. Number 11, again, I could tell what he's getting wrong. Here's a shoe, an ankle boot, and this is a thing I think is a pair of sandals, but it could also be an ankle boot. I think these are sandal straps, but they could be stripes on like a sneaker. So that's the thing. I can understand why it's getting these wrong. These are, just like you would think, the ones where the picture is sort of in between one category or the other, where it's going to make mistakes. All right. And I think I found some flags. You can train it for 25, and this introduces you to overtraining. We trained it for only like 5 or 10 epochs. If you train it for more, the error will go down, but often what happens is, at a certain point, the error goes down for the training set, but it's not getting better for the test set. So what you're doing is you're matching little variations in the training data that aren't real, fooling yourself, and its actual accuracy with the other test images is not getting better, and they call that overtraining. So it is an issue with the machine learning. You can train your model too much to where it doesn't actually do any better. All right. And then, all right. There's a flag or two to find there. So that's it for that one. And I got one more to show you.